of the density is determined. Let's take a foam sample with a weight of 100 kilos and a volume of 1 cubic meter. The density is the weight divided by the volume, therefore 100 divided by 1, thus 100 kilos per cubic meter. Let's now take another foam sample with the same weight and volume, but containing a pinhole of a volume 0.2 cubic meter. The density will still be 100 divided by 1, therefore 100 kilo per cubic meter. On the other hand, the real density is equal to 100 divided by the real volume used by the foam, meaning that we have to deduct the pinhole volume. Therefore, 100 divided by 1 minus 0.2 equals 125 kilos per cubic meter. To sum up, we have two foam pieces of the same weight, 100 kilos, thus offering the same support level but with two different real densities. We are now going to demonstrate what we just explained. Here are two pieces of the same dimensions and of the same foam densities. Here is a Sapsa latex core with a real density of 63 kilos per cubic meter. The second core comes from one of our competitors and has a real density of 75 kilos per cubic meter. The real density is the concentration of the foam, therefore for the same total volume, the more pinholes you have, the more concentrated will be the foam between the pinholes. Therefore, the higher will be the real density. This doesn't mean that there is more material. There is the same quantity of material, even a bit less, but most of all there is more empty space. We will check that by weighing the two cores. Let's weigh the core from the competition of density 75 kilos per cubic meter. It weighs 1,200 grams. Let's now weigh the Sapsa latex core of density 63 kilos per cubic meter. It weighs 1,250 grams. With less pinholes volumes, it is therefore the core of inferior density that is heavier. It is this core which will bring the best support. The resilience is the capacity of the foam to recover its initial shape after having been deformed. It is a synonym for elasticity. In order to assess this resilience, we are going to use this device. We put the foam core under this plate. The plate will go down, measure the thickness of the core, and sink until 70% of the thickness measured. Then the plate will go up progressively. We can see here on the screen a curve of the force registered by the plate according to the sinking. On the way down, the plate pushes the foam. On the way up, it is the foam which pushes the plate. The space between the two curves corresponds to the energy that was not restored by the foam. The closest of the two curves, the best is restored the energy. This means that the material will recover quicker after having been deformed. This means it is more resilient and that we will have a more dynamic support. We will now do the experiment with the PU core. We can see that the two curves are very far from one another, which means that PU restores little energy and is not elastic. Another characteristic, the knee effect. At the beginning, the curve goes up very quickly, which means the foam resists and that we have a low comfort. Then the foam suddenly collapses. On the other hand, the latex curve increases regularly, and we therefore have a progressive comfort all through the night. In this experiment, we are going to compare the height of the bounce of a metal ball on various materials. The more the ball bounces, the more the material is elastic. We measure first of all the bounce of a ball on a block of memory foam. We see very clearly that it has no bounce. The sleeper is very stuck during his sleep. Now on a Sapsa latex core, the ball bounces relatively high. Our latex is sharply more elastic, which facilitates the movements of the sleeper and allows a better rest. On the same idea, we measure the bounce of similar metal balls on a Sapsa latex core on the left and on the latex core from the competition on the right. We notice clearly that the ball bounce is higher and longer on the Sapsa latex core. This experiment demonstrates clearly the elasticity of our latex, which brings to the sleeper a better anatomic comfort. We are going to inject an equal quantity of ink on various cores to put in evidence the permeability of materials. On the PU, the ink slides completely. It does not manage to infiltrate into the material. On the core of memory foam, the ink also stays in the surface and does not penetrate the core. On the other hand, on the latex, we notice that the ink penetrates immediately and crosses the core. This experiment demonstrates successfully that the Sapsa latex is permeable. The air can circulate freely inside the core. The mattress will thus be perfectly ventilated throughout the night, and the perspiration of the sleeper naturally eliminated. Another way of measuring the permeability of a core consists in the use of pressurized air on one side and measuring the impact on the seats on the other side. On the PU core, seats remain immovable. On the SAPSA latex core, seats fly away. The air circulates. The mattress is perfectly ventilated.
Vision, spirit, creativity, forces that drive discovery and innovation, forces at work in American industry, improving life today, inspiring progress tomorrow.
Technology has been taken to extremes to provide comfort in a variety of outdoor settings. Today, it's being used to improve every facet of your life, from the bedroom to the boardroom, and from the ski slopes to the ski lodge. While using a technology originally developed for NASA, Outlast Technologies uses unique blends of thermocules to balance temperature in a variety of products you're in contact with every day.
The concept for Outlast Technology goes back all the way to 1988. NASA was looking to make new technologies to make spacesuits better. They came up with something called phase change materials, PCMs for short. Well, these phase change materials turn out to be really useful in all kinds of applications, all the way from suits to shoes and boots to outdoor jackets, gloves, and even in packaging applications, and even in military applications, things like bulletproof vests. Outlast has grown, developing these applications with partners, and now we can find the product all across the world.